In 1875, representatives from multiple nations gathered to sign what became known as the Metre Convention, a formal agreement intended to unify weights and measures across borders. Officially, the document marked a turning point in scientific cooperation designed to eliminate confusion in trade, engineering, and industry. The language surrounding it was confident and procedural, presenting standardization as a necessary correction to centuries of inconsistency. Yet, as I examined measurement manuals, engineering tables, and construction records from the decades preceding this agreement, something unusual began to appear. Long before international treaties existed, remarkably consistent units of length, weight, and proportion were already in use across vast regions. Stone masonry aligns with predictable intervals. Mechanical tolerances repeat across workshops separated by geography. Land divisions follow ratios that appear coordinated rather than accidental. These earlier standards were not publicly debated when they were replaced. They were not documented as failures. They were simply renamed, recalibrated, and absorbed into newer systems. Because modern infrastructure depends entirely on standardized measurement, the quiet replacement of earlier unified systems raises a question that remains unresolved. What was replaced in the name of progress, and why did no explanation seem necessary? When I began examining the history of measurement, I started with the explanation most commonly presented in textbooks, museums, and academic summaries. According to the accepted narrative, pre-modern systems of measurement were fragmented, inconsistent, and inherently unreliable. Each region, it is said, relied on its own local units, feet, cubits, stones, rods, often defined by the human body or regional custom rather than by precision. This narrative emphasizes variability. A foot in one city differed from a foot in another. A pound in one kingdom was heavier or lighter elsewhere. Measurement in this view was an obstacle to large-scale coordination. Trade was complicated, engineering was imprecise, expansion required constant conversion and correction. The emergence of scientific standardization is presented as a rational response to this disorder. I examined historical overviews that frame early measurement as symbolic rather than technical. Units are described as cultural artifacts, suitable for small-scale societies, but incompatible with industrial complexity. This interpretation suggests that true precision only became possible with modern instruments, centralized institutions, and international cooperation. Within this framework, the Metre Convention appears inevitable. A single universal unit, defined mathematically rather than culturally, is presented as the culmination of scientific maturity. Earlier systems are treated as transitional steps, useful in their time, but fundamentally flawed. This explanation also relies heavily on abstraction. Measurement units are discussed in isolation, detached from how they were applied. A cubit is presented as approximate because it derives from the human arm. A foot is treated as arbitrary because it varies. Rarely is attention given to how these units functioned within larger systems of construction, land management, or manufacturing. As I reviewed museum displays, I noticed that early measurement tools are often framed as crude. Wooden rulers, stone weights, and balance scales are displayed as precursors rather than as instruments in active systems. Their role is to demonstrate how far modern science has advanced. The official narrative assumes a linear progression, from imprecision to precision, from local custom to universal law. In this model, inconsistency is the defining feature of the past. Standardization is framed as rescue. Yet even within this explanation, certain assumptions remain unexamined. If pre-modern measurement was truly chaotic, how did large construction projects maintain alignment over long distances? How did mechanical components fit together reliably across workshops? How did land surveys remain stable over generations? These questions are usually dismissed as anomalies or attributed to exceptional craftsmanship. The broader implication that earlier societies may have operated within shared measurement frameworks is rarely considered. At this stage of my research, I accepted the official narrative as a baseline. It was coherent, widely supported, and institutionally reinforced. But coherence alone does not account for everything that remains physically present in the historical record. As I moved from summaries to material evidence, that narrative began to feel incomplete. The first contradictions appeared when I shifted focus from written explanations to physical remains. I began examining architectural plans, surviving structures, and engineering drawings from the pre-industrial period. What stood out was not variation, but repetition. Stone blocks in bridges and fortifications, separated by time and geography, often conformed to nearly identical dimensions. The tolerances required to achieve such uniformity exceed what one would expect from purely local or approximate systems. In some cases, masonry joints align with precision measurable in millimeters, despite being produced without modern machining. I also examined early mechanical components. Gears, shafts, and fasteners recovered from workshops and industrial sites show standardized diameters and spacing. These components appear designed to fit within predictable frameworks, not improvised individually. The official explanation attributes this to skilled craftsmanship, but skill alone does not explain repeated dimensional consistency across regions. Land measurement presented another anomaly. Survey maps from different empires reveal consistent ratios in field divisions, road spacing, and urban layouts. Even when local units carried different names, their proportional relationships remained stable. This suggests translation rather than reinvention. What struck me was how rarely these patterns are discussed. Measurement is often treated as a theoretical concept rather than as an operational one. But in practice, systems reveal themselves through use. If earlier units were truly incompatible, their use would leave visible discontinuities. Instead, what remains suggests continuity. I also noticed that when discrepancies are acknowledged, they're framed as exceptions. A precise structure is described as unusually advanced. A well-aligned machine is labeled innovative. The broader question, whether such precision was systemic, is avoided. Another anomaly emerged in documentation. Construction manuals and engineering guides often assume shared understanding. Instructions reference units without explanation, implying that the reader already understands their meaning. This level of assumption is inconsistent with the idea of chaotic measurement landscapes. Even more telling was the absence of conversion tables in many records. Where local systems supposedly differed dramatically, one would expect extensive guidance on translation. Instead, documents move fluidly between regions, suggesting compatibility. None of this proves the existence of a global standard, but the accumulation of consistent precision challenges the idea that pre-modern measurement was fundamentally unreliable. The physical record does not reflect confusion, it reflects order. At this point, I did not claim an alternative explanation. What I could say was that the official narrative did not fully account for what survived. The evidence suggested that measurement, as practiced, may have been more unified than is described. This realization prompted me to expand my scope beyond individual sites and artifacts. If consistency existed, it should appear not just locally, but globally. When I began comparing measurement evidence across continents, the patterns became more difficult to dismiss. Architectural spans in Europe align proportionally with parts of Asia. Land divisions in Africa mirror ratios found in the Americas. Names of units differ, but their internal logic remains strikingly similar. I examined temples, civic buildings, and infrastructure projects attributed to different cultures and empires. Despite decorative differences, the underlying measurements often conform to repeating intervals. Columns align with predictable spacing. Stair risers follow consistent heights. Structural loads distribute according to familiar ratios. Maps reinforced this impression. Urban layouts across unrelated regions display similar modular planning. Street widths, block lengths, and public spaces follow proportions that appear standardized rather than spontaneous. This consistency persists even in regions assumed to have had no direct contact. What made this more compelling was timing. Many of these patterns appear within overlapping historical windows. They are not separated by centuries of drift. Instead, they suggest concurrent use. Imperial administration offers one possible explanation. Large empires require uniform systems to function. Taxation, construction, and logistics depend on predictable measurement. The evidence suggests that such systems may have existed beyond what modern narratives acknowledge. I also noticed that when these older standards are discussed, they are often treated as isolated traditions. A Roman unit is described separately from a Chinese one. An Ottoman measure is framed as culturally distinct. The focus remains on difference rather than equivalence. Yet when translated numerically, many of these units converge. Their ratios align closely enough to allow interchange with minimal adjustment. This raises the possibility that they were not independently derived, but adapted from shared frameworks. This does not require a single global authority. Shared standards can spread through trade, engineering practice, and administrative necessity. What matters is that the evidence suggests convergence rather than fragmentation. The question then becomes why this convergence is not emphasized. Modern narratives highlight diversity in measurement to justify later standardization. But if earlier systems were already compatible, the rationale for abrupt replacement becomes less clear. At this stage, the investigation shifted from whether consistency existed to how it functioned. Repeating patterns imply structure. Structure implies systems. Understanding measurement as a system rather than as isolated units became essential. As I assembled the evidence, a system-level interpretation began to emerge. Measurement in the pre-industrial world appears not as a collection of arbitrary units, but as an integrated framework embedded in administration, engineering, and construction. In this context, units of length, weight, and volume do not operate independently. They interlock. Architectural proportions depend on length. Structural loads depend on weight. Material quantities depend on volume. Consistency across these domains suggests coordination. I examined engineering manuals that assume predictable relationships between dimensions and materials. Instructions reference ratios rather than absolute values, implying that practitioners operated within shared proportional systems. This approach allows flexibility while maintaining coherence. Such systems would not require abstract scientific definitions. They would require reliable replication. A unit need only be consistent enough to produce predictable results. The evidence suggests that this condition was met. I also noticed how these systems align with administrative needs. Taxation depends on land measurement. Military logistics depend on weight and volume. Construction depends on predictable materials. A unified measurement framework simplifies governance. Importantly, this interpretation does not require lost knowledge or advanced technology. It requires organization. Systems emerge where coordination is necessary. The question is not whether earlier societies could measure precisely, but whether they needed to. The abrupt replacement of these systems becomes more interesting in this light. If measurement functioned systemically, replacing it would require recalibration across multiple domains. This would not be trivial. Yet historical records describe the transition as smooth. Old units were renamed, redefined, or mapped onto new standards. This suggests compatibility rather than failure. What raises questions is the framing. The replacement is presented as correction, not conversion. Older systems are described as obsolete rather than integrated. This framing obscures continuity. If measurement was already systemic, then the introduction of new standards may have been less about solving chaos and more about restructuring authority. Centralized definitions allow centralized control. This does not imply intent or suppression. It suggests shifting priorities. Scientific institutions favor abstraction. States favor uniformity. Older systems embedded in practice may have been inconvenient. Chapter 4 is central because it offers coherence. It connects anomalies, patterns, and transitions without requiring extraordinary claims. Measurement appears not as primitive confusion, but as functional order. Understanding this reframes the replacement not as progress alone, but as transformation.
With a system-level understanding in place, I returned to the historical transition itself. The replacement of older measurement systems was not dramatic. It occurred through treaties, legislation, and educational reform. Units were not abolished outright. They were redefined. A foot became a fraction of a meter. A pound became a defined mass. Familiar names persisted while their meanings shifted. What stood out was the absence of public debate. Measurement touches daily life. Changing it affects trade, construction, and labor. Yet records show little resistance. The transition appears administrative. This may be because the systems were compatible. If older units mapped cleanly onto new ones, disruption would be minimal. This supports the idea of prior coherence. Educational narratives played a role. Textbooks reframed history, emphasizing inconsistency before standardization. Over time, this narrative became accepted. Archives also changed. Older manuals were sidelined. New definitions became authoritative. Continuity faded from memory. I found no evidence that earlier systems were tested and found lacking. Their disappearance appears procedural rather than evaluative. This quiet replacement is significant. Systems that fail usually leave records of failure. Systems that are replaced without comment suggest alignment with new frameworks. Measurement became abstracted. Instead of being embedded in practice, it became defined by institutions. This shift mirrors broader changes in governance and science. By the time global standardization was complete, earlier systems were remembered only as curiosities. Their systemic nature was forgotten.
Today, standardized measurement underpins every aspect of modern life. Global trade, engineering, and digital systems depend on it. This dependence makes the history of measurement more than academic. As I reflect on the evidence, what stands out is not loss, but forgetting. Earlier systems appear to have functioned effectively within their contexts. Their replacement was quiet, efficient, and unquestioned. The evidence suggests that measurement once operated as a practical system embedded in daily life. Modern standardization abstracts that system into definitions. This does not imply that modern standards are inferior. It raises questions about what was gained and what was set aside. If earlier systems were compatible, why was their existence reframed as chaos? If they were inefficient, where is the evidence of failure? These questions remain open. The physical record suggests continuity. The narrative suggests rupture. Understanding this tension matters because it shapes how we interpret progress. Systems do not emerge from nothing, they evolve. The story of measurement is not one of ignorance corrected by science. It may be one of systems replaced by institutions. What other systems have we accepted without revisiting what came before? These are not conclusions, they are invitations to look again.